Hello everyone, welcome to the lecture series on business mathematics. So this is our second lecture of this lecture series. So before moving further, let us quickly recall what we discussed in the last lecture. As you know that in last lecture we discussed about the sequences and series, right? So we give the definition of sequence, we discuss several examples, we also define what is called a series and examples of series. Then we define what is called a progression. Okay, we discussed that we are going to focus on progression portion. We are going to define what is called a progression, and we are going to discuss three different type of progressions during this lecture series. We are going to discuss about arithmetic progression, harmonic progression, and geometric progression. Right. So in last lecture we have already defined what is called the arithmetic progression. Okay, and we also discussed certain examples. We discuss the difference between a sequence and a progression. So what is the basic difference between a sequence and a progression? We discussed that sequence can be a logical rule, right? We discussed that every progression is a sequence, but every sequence need not to be a progression. We discussed a counter example also, sequence of all the prime numbers, right? So it is a logical rule. It is a logical rule sequence of prime numbers, but it is not a progression as we cannot have any general formula to find out the nth term of sequence of prime numbers. So it is an example of progression which is not a sequence. Also, we discussed the formula to find out the nth term of arithmetic progression. Suppose we are having an arithmetic progression of the form a plus d, a plus 2d, and so on, right? Then we discuss that here D indicates the consecutive difference, A indicates the first term. Then we discuss that the nth term of the progression, arithmetic progression, is given by A plus n minus 1 times D, right? So suppose you are having an arithmetic progression. If you know the first term and if you know the consecutive difference, then you can easily find out any terms of given arithmetic progression, right? So this is what we discussed in last lecture. So let us move further and let us see about the sum of arithmetic progression. Sum of arithmetic progression. So particularly we are going to find out the sum of first n terms of an arithmetic progression, right? So what we'll do, we'll begin with an arithmetic progression and we'll see, we'll try to find out a formula to have the sum of first n terms of arithmetic progression. Okay, so for that, let us begin with an arithmetic progression. Let a plus d, a plus 2d, and so on. So what will be nth term? It will be a plus n minus 1d be given arithmetic progression. Okay, now let Sn denote the sum of first n terms of given arithmetic progression, right? That means what is Sn? What is Sn? It is the sum of first n terms. Here you can observe that the first term is a, second is a plus d, third is a plus 2d, and nth term is a plus nd. So from this we get Sn is equal to a plus d plus a plus 2d up to a plus n minus 1d, right? Say this is expression number 1. Now I am rewriting this sum Sn, right? How? I am writing down the last term first, a plus n minus 1d plus second last term. It would be a plus n minus 2d. Continuing this process, what will be the second last term? A plus d, and last term is a. Say this is expression number 2. Now, why both these are equal? Because we know that for numbers, a plus b is equal to b plus a, right? This is well known property of numbers. And what does this mean? This means that either you add b in a or you add a in b. In both cases, you will get the same answer. Right? Once again, this a plus b denotes that you are adding b in quantity a. Here, you are adding a in quantity b. Both will give you the same answer. And this property is said to be commutative property. Right? So, whenever for some mathematical operation, this kind of property holds, then we say that this operation is a commutative operation. So addition is commutative. That's why we can rearrange the terms of this addition expression. Okay. Now what I am going to do, I am going to add these two expressions. Adding expressions 1 and 2, we get, so first of all adding the left hand sides, Sn plus Sn, Sn plus Sn. On right hand side, I am adding term wise. So adding first term with first, second with second, third with third, and so on. So first I am having a plus n minus 1d. Adding second term with second, we are getting a plus d plus a plus n minus 2d. Continuing this way, what about the last one? In last, we are getting a plus n minus 1d plus a. Okay. So now let us simplify this. So on left hand side we are having Sn plus Sn. So it will give you twice Sn. Okay. Now see here. This is a plus a. That is 2a, and this is plus n minus 1d as it is. So first term will be 2a plus n minus 1d. Let us simplify the second term. Again a plus a, that is 2a is there, and here we are having d plus n minus 2d, right? So d plus n minus 2d, simplifying it as nd minus 2d. So d minus 2d, that is minus d. So this will give you nd minus d. Taking d common out, we are getting n minus 1d, right? So this is 2a plus n minus 1d, right? That is simple calculation. So second term is 2a plus n minus 1d, right? Let us see the last one. A plus n minus 1d plus a, again a plus a, that is 2a. So last term is also 2a plus n minus 1d, right? So you can see that each term is reduces to 2a plus n minus 1d, right? 2a plus n minus 1d plus 2a plus n minus 1d plus 2a plus n minus 1d up to plus 2a plus n minus 1d. How many times? N times, because we are having n terms. Okay. So let us simplify this. 2Sn 2Sn is equal to, now see, this is 2a plus n minus 1d plus 2a plus n minus 1d plus 2a plus n minus 1d. How many times? N times. So this will be n into 2a plus n minus 1d. Why? Because we know that 1 plus 1 plus 1 plus 1 up to plus 1 n times. So this will give you n, right? X plus x plus x plus x n times, you will get n into x. So similarly, 2a plus n minus 1d plus 2a plus n minus 1d plus 2a plus n minus 1d n times, it will give you n times 2a plus n minus 1d. Okay, so let us simplify little bit more. Sn is equal to, taking 2 on left hand side, we will get n by 2 2a plus n minus 1d, and this is the formula to find out the sum of first n terms of an arithmetic progression. Now see here, what did I say? I said that taking 2 on the left hand side, right? But actually there is no such operation in mathematics, taking any number from left to right or right to left. What we are doing here, instead we are dividing this equation with 2 on both the sides, right? Once again, I am not taking 2 on the left hand side. Usually we are saying that taking 2 on left hand side, here it is in multiplication, so it will be in division. If some number is in addition, if you take on the right hand side, then it will become subtraction. But this is not the fact. Here what we are doing, we are dividing this equation with 2, right? So 2 upon 2 cancel out 1, and here it will be n divided by 2, right? So this is the formula to find out sum of first n terms. Let us simplify a little bit more. We have to remember this formula, okay? But for the sake of simplicity, let us simplify a little bit more. I am writing this 2a as a plus a plus n minus 1d. Why? See the last two terms. What is this? This is the last term. This is the last term or nth term of given arithmetic progression. Okay. So here this one is the first term and this one is the last term. So simply you can also remember this as Sn is equal to n by 2 a plus L, where L is the last term of given arithmetic progression. Okay. So this is a simple way to remember the formula. Otherwise, we are going to use this formula, right? Suppose we are having an arithmetic progression, then sum of first n terms is given by this formula. Sn is equal to n by 2, 2a plus n minus 1d. That means to find out the sum of first n terms, we require n, we require a, and we require d. If we are having these three quantity, that means how many terms you want to add? You should know the first term and you should know the consecutive difference. If you know this many things, then you can easily find out sum of first n terms. Let us see a simple example, right? So let us take the arithmetic progression of even positive numbers. So let 2, 4, 6, 8, 10 be given arithmetic progression. Find the sum of first, say, 10 terms, right? So here we are having an arithmetic progression and we are asked to find out the sum of first 10 terms, right? So let us see here n is equal to 10 because we are asked to find out sum of first 10 terms. What is a? That is the first term. First term is 2. And what is d? D is the consecutive difference. Consider any two consecutive terms and find out the difference. 8 minus 6, that is 2. Right? Just now we discussed that the formula to find out nth sum of first n term is given by n by 2 twice a n minus 1d. That means we require n, a, and d. So here I am having all these three values. Okay. So let us note down the formula. We know that the sum of first n terms of an arithmetic progression is given by, what is the formula? Sn is equal to n by 2 a plus n minus 1d. Now let us put the values. Sn, n equal to 10 here. So S10 is equal to 10 by 2. A, what is A? A is equal to 2 plus n minus 1. What is n? N is equal to 10 in this case. 10 minus 1. D, what is D? D is equal to 2 here. So 10 divided by 2, it is 5. We know that. 2 plus 10 minus 1. 10 minus 1, that is 9. And 2 as it is. So this is 5 multiplied with 2 plus 9 into 2, that is 18. Right? It is 18. Notice 18 plus 2. So it is 5 times 20. And we know that 5 into 20, that is 100. So therefore S10 is equal to 100 in this case. And this is your answer. Right? You know that very simple formula. You have to just remember the formula. You have to find out the value of n, a, and d. Use these values and you will get the sum of first n terms of given any arithmetic progression. Be careful that this formula is applicable for arithmetic progression only. Let us see one more example. First of all, let us see the question. If for a sequence if for a sequence an, Sn is equal to 2 into 3 raised to n minus 1, then find find first four terms find first four terms of this arithmetic progression. Right? Okay. So see, now this question is different from the last one. In last example, we were having an arithmetic progression. We are having the terms of arithmetic progression, and we were asked to find out its sum of first 10 terms. But here the question is reverse. Here we are given sum of first n terms of an arithmetic progression is given by this formula, right? And what we are asked? We are asked to find out the terms of this arithmetic progression. Okay. So see, whenever you are having sum of first n terms and you are asked to find out any kind of terms of arithmetic progression, then what you have to do, you have to find out the formula. You have to find out the formula to find the nth term of this arithmetic progression. Okay. Once again, whenever this kind of question occurs, right, what is the method? You have to find out the formula for nth term. And how it is possible? How it is possible? Let us see how it is possible. See, the sequence an is given. In last lecture, we did discuss that if you are having a sequence an, then it is given by a1, a2, a3, a4, and so on, right? So let us see. Let a1, a2, a3, a4 be given sequence, right? What is the other thing we are having? We are having that Sn is equal to this one. So what is Sn? What is Sn? Sn is the sum of first n terms. So Sn is equal to a1 plus a2 plus a3 up to an, right? And what is this? This is equal to twice 3 raised to n minus 1. Okay, twice 3 raised to n minus 1. Now, how to find out the nth term of this arithmetic progression? So see, here we are having the formula for Sn. So from this you can easily write down formula for Sn minus 1. What is Sn minus 1? Sum of first n minus 1 terms. So simply in this expression replace n with n minus 1. What will you get? 2 3 raised to n minus 1 minus 1, right? Simply replacing n with n minus 1, we are having formula for Sn minus 1. Now why I have find out the Sn minus 1? See here, I have written a1, a2, a3 up to an. So what will be this Sn minus 1? It will be a1 plus a2 plus a3 plus up to an minus 1. Now what I want to find? I want to find out an. So I hope you can guess how to find out an using these two expression. Subtract Sn minus 1 from Sn, right? So a1 will get cancelled out, a2 will be cancelled out, a3 will be cancelled out, an minus 1 will be cancelled out. What is remaining? Only an, right? So whenever you are having the value of Sn, then first of all find out Sn minus 1, subtract this Sn minus 1 from Sn, you will get the value of an. That means formula for nth term of arithmetic progression. Now once you are having the formula for an, then put n equal to 1, you will get the first term. Put n equal to 2, you will get the second term. N equal to 3, you will get the third term, and so on, right? So therefore Sn minus 1, and we know that Sn minus 1 is nothing but the n. I'm directly writing down n, and you know how. A1 plus a2 plus a3 plus up to an minus a1 minus a2 minus a3 up to minus n minus 1. All this term will get cancelled out, only n will there. This is equal to, what is Sn first of all? It is twice 3 raised to n minus 1 minus Sn minus 1, and Sn minus 1 is this one, twice 3 raised to n minus 1 minus 1, right? So therefore an is equal to, you can observe that we can get 2 common out from these two terms. So taking 2 common out, what is remaining? 3 raised to n minus 1 minus 3 raised to n minus 1, and this minus minus becomes plus. Okay, minus minus becomes plus. So you can observe that this 1 and 1 get cancelled out. What is remaining? Twice 3 raised to n minus 3 raised to n minus 1. Okay, so let us simplify a little bit more. Therefore an is equal to, now see here, what we are having? 3 raised to n minus 3 raised to n minus 1. So I am rewriting this 3 raised to n as 3 raised to n minus 1 into 3 minus 3 raised to n minus 1 as it is. See here, Here we are having 3 raised to n, right? So this 3 raised to n can be written as 3 raised to n minus 1 into 3, and this 3 raised to n minus 1 as it is, right? Why we have done this? Because now this 2 as it is, you can take 3 raised to n minus 1 common out. So into 3 raised to n minus 1, what is remaining? Here remaining is 3 only, minus sign is this, and here the whole term is taken outside common, so only 1 is there, right? So simplifying this, we are having an is equal to this one. So an is equal to now 3 minus 1. 3 minus 1 is 2. 2 into 2, that is 4 into 3 raised to n minus 1. So now this is the formula to find out nth term of given arithmetic progression, right? So we got the formula for an. Now our task is very much easy. What is the question? Find first four terms, right? So what we'll do, we'll take n equal to 1 in this expression, we'll get a1. We'll take n equal to 2, we'll get a2, and so on. So let us see what happens if we take n equal to 1. So we get a1 is equal to 4 into 3 raised to n minus 1, n equal to 1 here, so 1 minus 1. So it is 4 into 3 raised to 0, and something raised to 0, that is 1. So it is 4 into 1. So from this we are getting a1 is equal to 4. Right? So we got the first term of our arithmetic progression. Let us find out the second one. Let n equal to 2, we get a2, that is equal to, put n equal to 2 here, 4 into 3 raised to 2 minus 1. So that is 4 into 3 raised to 1. So 4 into 13, that is 12. So this implies that a2 is equal to 12. Let us take n equal to 3. Let us see what happens. So here we get an, that is a3. 4 into 3 raised to n minus 1. So 3 raised to 3 minus 1. So it is 4 into 3 square, and we know that 3 square, that is 9. So 4 into 9, and this implies that 9 into 4, that is 36. A3 is equal to 36. Right? We are asked to find out first four terms. So we already get the first three. Let us take n equal to 4. You will get the fourth term also. A4. A4 is equal to 4 into 3 raised to n minus 1, and n equal to 4. So 4 minus 1, 3 cube. So 4 into 27. So this implies that A4 is equal to 27 into 4, and that will be 108. Right? So this is your answer. Okay. So very much simple mathematics we have used. Let us quickly recall what we have done in this example. Here we are given that sum of first n term is given by this expression, and we are asked to find out first four terms of such arithmetic progression. So we begin with a sequence a1, a2, a3 up to infinity. Then Sn will be a1 plus a2 plus a3 plus up to an, and this is given by this formula. So using this Sn, what will be Sn minus 1? Replacing n with n minus 1, we get the expression for Sn minus 1. Now subtracting Sn minus 1 from Sn, we are getting the value of an, and we are having formulas S and Sn minus 1, right? So Sn minus Sn minus 1, simplifying this, we are getting the value of an, and an is equal to 4 times 3 raised to n minus 1. And since we are asked to find out first four terms taking n equal to 1, we are getting first term, taking n equal to 2, we are getting a2, that is second term, n equal to 3, third term, n equal to 4. fourth term, right? And this is your answer. Okay, so I think this is enough for today. We'll continue discussing examples on arithmetic progression in the next lecture also. Thank you.